Today on How It's Made. Combination locks. Security that's got your number. Pottery. When they made these, they didn't throw out the mold. Recreational vehicles. Comfy accommodations that go the distance. And erasers. Mistake menders that tend to rub off on you. Combination padlocks are what students depend on to protect their lockers from thieves and pranksters. Combo locks are functional, yet fashionable. Like everything else marketed to teenagers these days, they come in a variety of trendy colors and designs. The combination lock's main locking mechanism is called the base plate. It's comprised of 7 components. That black piece, called the lock bolt, is what slides over to free the shackle when someone dials the correct combination. They rivet the base plate components into place so the lock will stand up to repeated use. Here are those components before assembly and after. They secure the assembled base plate into the casing. Then they install the trip lever spring. It's what automatically scrambles the mechanism every time the lock is closed. They fit the shackle through holes in the casing, positioning one end against the trip lever. They fasten the other side with a tiny steel bar called a yoke. The lock's combination function is made up of 3 stacked discs called tumblers. Here, the first 2 go in. Next, they grease the shackle so it'll slide in and out easily. Sometimes they customize the face of the lock. Those number dials used to come in just boring standard-issue steel. Today, they can have colorful designs, even a school's logo. The printing machine uses a 4-color printing process, applying 1 color at a time. The painted dials get 2 coats of clear varnish to harden and protect the paint. While that's happening, other workers assemble the dial components. First, they take the indicator button and attach it to the dial. Then they take the 3rd tumbler and rivet it to the back of the dial. This tumbler will control the movement of the 2 other tumblers inside the lock's casing. All 3 tumblers have V-shaped indentations. The correct combination aligns those V's, allowing the lock bolt to slide over and free the shackle. Each tumbler has a code number stamped on the back. The number corresponds to the location of its indentation. They program each lock's 3 tumbler codes into a computer. The computer then randomly creates a combination that will align the 3 indentations. There are more than 50,000 possible combinations. The system prints the combination on a sticker, along with a barcode. The barcode is programmed into a central computer where it's recorded with the lock's serial number. The guts of the combination lock are finished. Now it's time for the final assembly. They put the dial onto the casing. Then a forming tool presses down on the casing's rim, folding it tightly over the dial. A computer-guided machine then engraves a serial number on each lock. Some factories do random quality control checks, But this company verifies each and every combination lock by hand. That's quite the procedure, considering this plant produces more than 10,000 locks a day. You can bet somebody's got pretty sore fingers by quitting time. As early as 11,000 BC, man was making utensils out of clay. This was the birth of pottery. Modern pottery is divided into 3 categories: porcelain, stoneware, and earthenware. What differentiates them is the mixture of clays and the firing process. This earthenware piece starts with a technical drawing based on an artist's conception. Following the specs, they use a series of specialized tools to sculpt a plaster model on an electric potter's wheel. They check the diameter with calipers. The model is 7% larger than the finished piece will be, to compensate for shrinkage that will occur during drying and firing. They sculpt some parts by hand and glue them on. Using this model, they cast a master mold made out of a rigid type of plaster called gypsum. They now use this master mold to cast a production mold out of rubber, or in this case, plaster. First, they pour in the plaster, using their hand to break up any air bubbles that would cause defects in the casting. They leave it to air dry in a warm room overnight. Once it's ready, they can extract it, a delicate operation that takes 15 minutes. This production mold has to cure for 48 hours before going into service. It'll be good for 200 castings. And it'll be identified by the model number on its side. Earthenware is made of talc, a mineral called nepheline syenite, a dark beige clay known as ball clay, another mineral called silica, and a white clay known as kaolin, all mixed with 40% water. They pour the mix into the production mold with careful, even pressure, again to avoid creating air bubbles. The plaster mold slowly absorbs the water, leaving behind a moist earthenware lining half a centimeter thick. After about a half hour, this lining hardens and they can dump out the surplus liquid. They cut off the excess earthenware at the top. Then, after another 45 minutes or so, extract the piece from the mold. Workers have to handle the earthenware gingerly, with even pressure. If one finger presses just a bit too hard, it'll show up as a dent, but only after the piece is fired. After a 24-hour drying period, workers then carefully shave off the seam left by the 2 halves of the mold. They rub the piece on wet stone to even out the top and bottom. Then they smooth the surface with a wet sponge. Unlike stoneware, which comes out glossy after firing, earthenware remains dull. So to make it shiny and colorful, they apply specialized glazes and enamel paints. Finally, they spray the piece from top to bottom in a transparent glaze to give it an overall sheen. Then it's off to a room-sized oven called a kiln, for an 8-hour firing, during which time the temperature climbs to more than 1,000 degrees Celsius, then a 2-hour cool down. The intense heat activates the pigments in the paints and makes the colors come alive, turning what was once a lump of clay into a work of art. Traveling in a recreational vehicle is like having your own personal motel on wheels. RVs are either motorized or towable. Towable ones range from folding tent trailers, known as pop-ups, to more elaborate travel trailers, complete with fully equipped bathrooms and kitchens. To make a travel trailer, workers first cut steel bars to build a frame. The saw has to be drenched in coolant, or it'll overheat due to the intense friction. They drill holes for the bolts and screws they'll later use to attach certain components. Then they solder the frame parts together. They run electrical wires through the frame, lining the holes with rubber grommets to keep the wires from rubbing on the sharp metal edge. Next, they install metal brackets to hold the water and septic tanks in place underneath the trailer. Then they torque the wheels to the axle. Now they install the gas lines. The stove, the fridge, and the heating system all run on propane. Next come the water and septic tanks, made of polyethylene, a heavy-duty plastic. They cut a hole in each tank and screw on a fitting. The tanks sit directly on the frame. The white ones for drinking water, the first black ones for the shower and sinks, and the second black ones for the toilet. To build the floor, they put down a waterproof membrane, then a spruce frame insulated with fiberglass wool, then 5/8 plywood, cutting vent holes for the forced air heating system. After sanding the joints and gluing down linoleum, they install the cabinetry and furniture. The plumbing fixtures come next. They connect to water lines coming up from the tanks beneath the floor. The water system is driven by an electric pump. While some workers put up the pre-assembled walls, others run wiring for the lights and appliances. The inside wall surface is vinyl paneling. Drywall would be far too heavy for an RV. The paneling's mounted on a pine structure insulated with fiberglass wool. They cover the outside in aluminum siding. Then they complete the electrical wiring for the lights and appliances. Now it's time to install the roof. Another pine structure with fiberglass wool insulation, covered with a thin wood called luan that's reinforced to withstand the extra weight of roof cargo. They cut out the various ventilation holes. Then apply a layer of glue. Then lay down a high-performance waterproof rubber membrane, nailing it down along the perimeter. They install vents for the toilet, the refrigerator, and for air circulation. They caulk all the joints and around all the vents. Last but not least, the windows, doors, awnings, and any optional equipment. Workers check the water, gas, and electrical systems, then do what's called a seal test. A special machine applies air pressure from the inside out. Wherever water bubbles, there's a leak to be repaired. With all the upholstery and other decorative elements in place, this comfortable travel trailer is ready to hit the road. Make no mistake about it, an eraser is a student's best friend. Whether it's attached to the top of a pencil or on its own, only an eraser can quickly rub out an error. White erasers are made of flexible vinyl, while pink erasers are made of synthetic rubber. In 1736, a French explorer observed South American native Indians using a certain tree resin to make bouncing balls. He brought this resin back home, and before long, Europeans discovered it could rub out lead pencil marks, hence the term rubber. There was just one problem. After a while, rubber would rot. That dilemma was solved a century later by one Charles Goodyear, who developed a curing process to prevent rubber from rotting. A lot of ingredients go into making a simple pink eraser. Carefully measured fillers, accelerators, curing agents, oils, coloring, and the main ingredient, synthetic rubber. They start by putting a batch of rubber into a mill. The rubber passes repeatedly between large heated rollers. They throw in any defective erasers from the last production run, recycling them into this new batch. Then they add sulfur as a curing agent, accelerators to help the sulfur do its job, and red coloring. They blend everything for 5 to 10 minutes until the mixture is the consistency of heavy dough. Next, vulcanized vegetable oil. That's vegetable oil treated with sulfur, then regular vegetable oil, then calcium carbonate as a filler. When the color and thickness are just right, workers remove the rubber, which by now is hot and soft as a result of all that milling. They leave it to cool and harden at room temperature for about half a day. When the rubber's ready, they cut out large squares, each weighing between 5 and 8 kilograms, depending on the thickness of eraser the client has ordered. The squares go into a steam-heated press to cure for about 20 minutes at 163 degrees Celsius. The pressure compacts the rubber, while the intense heat hardens it. They trim off the excess, then submerge the hot rubber squares in cold water to stop the curing process. To make erasers that erase both lead and ink, they cut beveled strips from 2 batches of rubber, one pink and one blue. The blue contains pumice, which gives it that extra abrasiveness to erase ink. They pair up each pink with a blue to form a 2-color strip. Then it's into the steam press. After 12 minutes, workers remove the trays, trim off the excess, and submerge the strips in cold water to stop the curing process. Then an automated machine chops the strips into pieces the size of erasers. Now back to the all-pink erasers. The rubber squares come out of their cold water bath and go through a machine that cuts strips with beveled edges. then chops the strips into erasers. From there, the erasers drop into a giant barrel. Workers throw in some talc to prevent them from sticking together. Then they set the barrels spinning for 3 to 5 hours. As the erasers tumble against each other, the abrasion rounds off their edges. The last step is printing. A machine stamps each eraser with the company name and the model number. It's not the rubber that gives the eraser the ability to erase, but rather the vulcanized vegetable oil that's in it. That's what makes the eraser crumble when rubbed on paper, taking away the pencil marks with it. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at www.howitismade.net. The How It's Made crew vehicle is courtesy of Subaru Canada.